Hello, hi everyone. Welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. And students, today we will be doing buffer solutions and solubility. So everybody, do let me know in the chat box if I am clearly visible and audible so that we can start with today's session. Yes, everybody in the chat box, let me also inform the students on the Telegram channel that we are live. Right? So, yes, students. So, buffer solutions, salt hydrolysis, pH of strong acids, strong bases, what is the problem here? The problem is that we just see the formula of buffer solution. This is for buffer solution formula. When to apply that formula? How you will understand whether it's a buffer solution or not? For that, you have to go in depth of buffer solution that I'm going to do today. Right? So let's start with it, guys, everybody. So first thing is, ma'am, what is a buffer? So buffer is something, let's say the pH of that solution is, let's say, is fixed, right? Then you add some acid into the solution. Even now you see no fluctuation in pH, you can observe. But according to you, when there is some, this is some solution that has, let's say, pH 6, right? You add acid here, HCl here, but even then the pH is fixed here, 6 only. That means you can't see the variation in the pH on adding acid or a base. Then it is called as a buffer when there is no change of pH in that. So solution which resists change in the pH when you add any acid or base here, right, on dilution or with addition of small amount of acid or alkali, there is no change of pH. That is called as buffer solution. Now, a very famous buffer solution is which one? A very, wait a minute. Uh, uh, uh. Hello. I just saw it. Okay, I'll just start with the. I don't know why I got stuck. So, have you not seen me? So, I'm so sorry about it. Yes, students, welcome to the class. Welcome to Vedantu J English. I am Diksha Kaushal, your chemistry master teacher, and today we will be doing buffer solution and solubility here. Right? Okay. Now, if you talk about buffer solution, pH of buffer solution, pH of salt hydrolysis, then you have pH of strong acid, strong base, pair of strong acid, pair of strong base. So many formulas are there. But in the exam, they will not tell you that this is a question of buffer, this is a question of salt hydrolysis, this is a question of strong acid and strong base pH. This you have to understand this yourself, right? So we'll talk about that, but first you will understand what exactly is buffer, how we came up with that formula, when to apply that formula, right? And the biggest mistake that students do is not understanding whether this is a question of salt hydrolysis or this is a question of buffer solution or it is a simple question of pH. And this is what we are going to learn, right? So let's understand that. First is buffers. Buffers are what? When the solutions which resist the change in the pH. For example, you have any solution, you added acid or a base into it, but still the pH is not changing. That is called a buffer. Now, which is a very important buffer, and you will see that example within you itself. That is your blood. Our blood is a buffer, right? So with certain change in like you add acid or base because of our daily life, things that we are doing, right, what we eat and everything, the blood buffer will not change. That means the pH of the blood will remain 7.4 only. It will not change whether you add acid or base into it, right? And that is beneficial for our body, that our blood pH is not changing, right? So pH meter stays the same. Whether you add acid or you add water or you add base, it will not change. That is called a buffer. So if you talk about, there are three kind of buffers that we will talk about. First is acidic buffer, then there is basic buffer, then there is salt buffer. Acidic buffer is a solution containing weak acid. It has a weak acid and it's salt with strong base. So you will have a weak acid and you will have its salt with strong base, that is called as. Now ma'am, can you give us some example? For example, you have CH3COH, which is a weak acid, and this is weak acid plus strong base salt. So weak acid strong base means this is a salt that is formed from CH3COH plus NaOH, and you have the formation of CH3COONa. That means the cation part is from strong base, the anion part is from weak acid, then it will make up acidic buffer, right? Then guys, if I talk about basic buffer, in basic buffer you have weak base, right? And it is having the salt with strong acid, right? And you have its salt with a strong acid. For example, weak base is like NH4OH. And its salt with strong acid means here NH4OH plus HCl. They together, these two things will form NH4Cl. That is a weak base and strong acid salt, right? Then there is next one, that is salt buffer. Now what do you mean by salt buffer? In this case, you will have a solution containing salt of weak acid and salt of weak acid and weak base. Salt of weak acid and weak base, like CH3COONH4. This is going to give you salt buffer, right? Now you might feel, oh, that is so easy, right? Acidic buffer, weak acid, and you want to have strong base there. But sometimes they don't give you salt. They give you one acid, they give you one base. So based on that, how you will tell what are the different ways of forming this acidic, basic and salt buffer, that we will understand to understand the core concept here, right? So if you see this, firstly let's understand the working of buffers. Let us consider an acidic buffer solution made up of CH3. Now how come the buffer is not changing its pH? Firstly, let's see, two things will focus on buffers. First thing that we will focus is working. Working means why pH is not changing. Second thing, we'll talk about how it is made. And these two things will help you. To understand how it is made, you have to understand the working first, right? So we'll understand the working of each of them, right? So first is acidic buffer. Achha, tell me one thing, acidic buffer is made up of which thing? How many of you will tell me? Strong acid, strong bases never form buffers even if mixed in the correct. That I'll talk about, Louis. I'll talk about different pairs also. Okay? Right now, tell me, acidic buffer is made up of weak acid and salt of weak acid with strong base, right? So let us consider an acidic buffer made up of a weak acid and a salt of weak acid with strong base, that is this. The weak acid dissociates to very small extent due to common ion effect of its salt. Now we are saying weak acid, right, that dissociates to very small effect. Now what is exactly there? If you see this thing, this is having two dissociation, CH3COH. This dissociates to CH3COO, negative plus H positive, isn't it? And ma'am, what about this? Now, if you remember, I told you that, do you remember one thing that I told you? I told you that all the salts are strong electrolytes. Whether it is formed from weak acid, weak base, strong acid, strong base, a salt will always be a strong electrolyte, right? So it is going to dissociate 100% here, right? Now, which is the common ion here? Can you see this over here? This is the common ion. And because of this common ion, right, what will happen? This particular concentration over here will increase. And that is the reason this reaction will, according to Lee-Chartley principle, this will start moving backwards, right? That means the dissociation of CH3COH, it will decrease because the reaction is backwards, right? So this is what they are saying. Weak acid dissociates to very small extent due to the common ion effect. So here the dissociation is less because of the common ion effect, right? Now what you will see, this you have seen that okay, common ion effect is there. This is giving you CH3CO negative. This is giving you CH3CO negative, right? Now its dissociation has decreased, right? Now let's say what you have added here is you have added water, right? When you have added water, this CH3COO negative will accept H positive here and O negative, OH negative will be there in the solution itself, right? Understood na? OH negative will be there in the solution because the CH3CO negative has accepted H positive from the water, right? Now, see this page. All the things will apply here, right? That is, this is the dissociation of CH3COH, which is again a weak acid. This dissociates into CH3COH negative, right? Start with 10 moles of CH3COH and 10 moles of CH3CO. That means now we have taken equal moles of weak acid and the salt of weak acid with strong base. This, why we have written it like CH3CO negative? Because a salt will always dissociate 100%, right? So we can write it in the form of anion as well, which is a common ion. Now we are adding 1 mole of H positive in this case, right? When you add H positive, it will react with 1 mole of this. See one thing. If you add water, it will take H positive from water and give OH negative to the solution, right? If you add directly acid, this CH3CO negative is going to accept H positive and get converted to CH3COH, right? If you have added 1 mole of CH3CO negative, then 1 mole of CH3COH will be formed. 1 mole of this, which is a very weak acid, this will again, the one that you have formed, this will produce less amount of H positive, and that is the reason, right? That is the reason very small change in pH is there. Understood na? pH will change if the extent of H positive or OH negative ions have changed. You already have CH3COH, right? Two factors are taking place here. If you see, first is this common ion effect that is there. Because of this, the dissociation is decreasing. This H positive will be decreasing. This H positive will decrease. Why this H positive will decrease? Because this reaction is moving backwards. Now, pH should increase when H positive ion is increasing. First factor of H positive was from this weak acid, which is already weak, and you're making it even more weak by adding this CH3CO negative. Now, this CH3COO negative, what it will do? It will accept H positive from the acid that you have added and be converted into again this CH3, which is further a weak electrolyte. So that means the production of H positive ion by whatever H positive ions you are adding, it is eaten up by CH3CO3, CH3COO negative. H positive that you are adding is not remaining in the solution as it is. H positive that you are adding is being eaten up by CH3COO negative and that is getting converted to this weak electrolyte which does not dissociate H positive. If the H positive dissociation is less, then how can the pH will be more acidic? Not possible. Understood? Tell me. Is that clear? This thing should be clear in your head why it is happening, why pH is not changing. You are adding H positive, those H positive are being eaten up by CH3CO negative, which is converting them into a weak electrolyte, which in turn is not getting dissociated, right? Furthermore, because of this common ion effect also, its dissociation is weak acid. Let's say it was dissociating, 30% dissociation was there. By this, maybe only 5% dissociation they are left with. So even less, you are adding H positive, but it is making no change because of this overall effect here, right? Okay. Giri, don't spam, right? I'll take that, but please don't spam, okay? Please don't spam, right? Okay, yes. Now let's see, ma'am, this so you told about H positive. What if, ma'am, I want to add base? Then what will happen? See, when you add base, right, you start with the same thing, equal moles of CH3COH and CH3CO negative. Now, you add 1 mole of OH negative. Now, OH negative will react with which one? Anion or cation? It will react with cation. And which is that cation? It will react with 1 mole of CH3COH to produce 1 mole of CH3COO negative. Ma'am, why so? See, OH negative wants to accept H positive, right? It wants to accept H positive. And H positive, if you see here, is only there with this. Only this acid has H positive. So it is going to accept H positive from the acid. It is going to eat this H positive, right? The OH negative is going to eat this H positive, and you will be left with CH3COO negative in the solution, right? To produce 1 mole of this. 1 mole of CH3CO negative will produce very less OH negative. Now we are saying that you have CH3CO negative. Now this 1 mole of, how can, ma'am, now the another question is, ma'am, how can this produce H positive? See, how it can produce H positive is 1 mole of this. If I talk about, you have water. From there, H positive and OH negative is there. So it will eat H positive and it will give off OH negative, right? So more it is eating H positive, more OH negative will be there in the solution. pH change will be high. Now, will it eat more H positive? Will be defined by, right? If you see CH3COH is there here, wait a minute, right? Is here and here. Because of again the common ion effect, the production of this CH3CO negative is very less. If CH3CO negative is not there, it is not going to eat H positive. It is not from water, it is not going to eat H positive. So it is going to give less OH negative, and that is the reason OH negative is less in the solution. Tell me, is that clear? Is that clear? Okay, tell me. Very good, Shiva, very good. Yes. Understood now what I am telling you? Working of buffers, what we discussed, students, again I am replying. See, common ion effect you have to understand. When you add H positive in the solution, the work of H positive is to get attached to CH3CO negative directly, right? And produce more of this weak electrolyte, weak acid, which is going to give less H positive, and hence the overall factor, overall change in pH will not be there. The more H positive you are adding, the H positive are already being eaten up by this one, and that's why, and they will produce less dissociation. So H positive increment is not that high. Second is when you add OH negative what it will do, it wants to accept H positive, so it will accept it from here, and it is now CH3CO negative. Now CH3CO negative, it has very less amount of overall in the solution, because of common ion effect you have less amount of CH3CO negative, right? And that is the reason less amount of H positive will be eaten by CH3CO negative, and hence less amount of OH negative will be there, right? Okay, yes everybody, tell me in the chat box, right? Is that clear? Right, so very small change in the pH will be there. So that is the example. Achha, this is the next example in the aqueous solution of, for example, in an aqueous solution of CH3CO NH4. Achha, this is the salt buffer, na? This is, wait a minute. Yes, this is, I think, salt buffer. Yes, so I'll just, let's see the salt buffer. If you see the salt buffer, that is CH3CO negative, NH4 positive, right? That is there. It will give CH3CO negative and NH4 positive because it's a salt, it is going to dissociate. Now, after that, when an acid is added, this ion consumes it to give CH3CO negative, which gives very less H positive. Now, when we say that when we add acid H positive, this ion will eat H positive, right? And that is why further dissociation of CH3COH will be less, and that is why no change in pH is there. When base is added, that is NH4. NH4 is a cation that will get attach OH negative, right? Because it is going to form NH4OH, which is again a weak base, which is a weak electrolyte. So less OH negative will be there in the solution. And that is the reason to give NH4OH, which is again a weak base, which gives less OH negative, and hence pH does not change much. And that is the reason salt buffer also do not give you this thing, right? Okay. Now, how many of you will tell me about on the similar lines, right? If I say, let's say you have an example, let's see if you can answer this or not. Let's see you have basic buffer, right? Let's see if you have basic buffer, will you be able to answer that or not, right? Let's see if you have basic buffer. What is a basic buffer? Because I have given you two things here where you can understand the basic buffer process, that what is happening, right? See, basic buffer is made up of weak base and salt of weak base with strong acid. So I can give it an example, NH4OH plus this will be NH4Cl, right? Two cases are there. One is when you accept H positive. One is, ma'am, when we accept H positive, let's talk about that, right? Accept, or you can say when we add H positive. Ma'am, when we add H positive. Now, tell me one thing. What is the reaction that must be happening there? NH4OH give rise to, this is a weak electrolyte, so it is going to get converted to this and this. And you have NH4Cl, that is getting converted to NH4 positive and Cl negative. Now H positive will be, what is the role of H positive here, right? H positive is going to take out, these are the lone pairs, right? It is going to get attached here, right? And it will take out this OH negative from here, right? And it is going to give you NH4 positive in the solution. More of NH4 positive in the solution will be there. More of NH4 positive in the solution, that means because of like so much NH4 positive, less production of NH4 positive will be there. So this reaction will start moving backward, right? So the H positive that you have added, right, that according to you is supposedly going to increase the H positive ion concentration and should change the pH But what is happening here? You are adding H positive, and this H positive, what it is doing, the moment you add H positive, more of this dissociation occurs, right? And that is the reason more of OH negative will be produced. So H positive you are adding, OH negative is also increasing, so it is going to balance out these situation, and hence overall effect will be zero here. Not zero, but not overall effect will be nil, almost nil you can say, right? And similarly, if I talk about the same situation, right? This is NH4OH. Now here if I say when you add OH negative, then what is going to happen? When you add OH negative, then what is going to happen here? Right? Okay. When you add OH negative, what is going to happen here? Here, acha, one more thing you must understand, right? One more thing, as you add H positive here, no, this OH negative is already there in the solution, though it's a weak, this is not a very strong dissociation is there, right? Here you don't have a very strong dissociation, right? If I say here you have 100 molecules, maybe 30-40% are getting dissociated, others are here only, okay? If you see this, here you add OH negative. If you add OH negative to the solution, then what will happen? When you add OH negative to the solution, you will have the formation of NH4OH, which is again a weak base. So you have added OH negative thinking that the pH will increase, but it will be taken by NH4OH, and that is the reason less dissociation, and that is the reason less OH negative will be produced here, and that is why overall change in pH is 0. Okay, overall change in the pH is going to be 0 here, right everybody? Okay, yes. So that was about this thing. Now let's understand the working that we have done, right? Yes, working we have done. Now let's understand the preparation. This point is extremely important here. Why this point is so important? Because of, if you don't understand the preparation part, you just know, okay, there is weak acid and salt of weak acid and strong base. What if they have given you weak base and weak acid, weak base and salt of weak base with strong acid, weak acid and salt of weak acid with strong base? Now what you can say about this? Now how you will tell which kind of buffer is there, right? Okay, now wait a minute. Then if they give you strong acid plus weak base, right? Strong base plus weak acid, all these pairs are also buffer, but you don't know it. So that is the reason you need to understand how to prepare it, right? So the preparation number one method is a very simple method that I told you from the definition itself, that you should have a weak acid, salt of weak acid with strong base. There should be a weak acid that you should have, and salt of that weak acid with strong base. Then here it is, you should have a weak base, strong of weak base, salt of weak base with strong acid. And this is weak acid and weak base. This is first method that most of the students know only about this method. But what about this second method? That is a method where they have given weak acid and strong base. But condition number one here, in the method number one, number of moles are same. Here you will see both of them will have same number of moles, right? But here number of moles will differ. And which one will be high? This weak acid. Number of moles of weak acid should be greater than strong base. Acha, understand one thing. Understand one thing. That if they have given you, let's say, okay, tell me one thing. If they have given you, this is also 10 moles, this is also 10 moles. Is this a case of buffer or not? Now, is this a case of buffer or not? Both the number of moles are same. In this case, you will write pH is equals to, in this case, this is a case of weak acid and strong base. This you will study in salt hydrolysis. Okay? This you will study in salt hydrolysis, right? So when number that we have not studied, that's why I erased it, right? So we have not studied it yet, that we will study, but the condition will be, you will see that number of moles, if they are same for this condition, then it is not buffer solution. Number of moles of weak acid has to be in excess. Let's see how, and how it will turn the situation immediately, right? So guys, if you see this here, this is a weak acid. Let's say there are 20 moles and this is 10 moles, right? So what you have here, in this case, 10 mole of, when they react, let's say out of this 20, 10 moles has reacted. Here 0 mole of this you have, and you will have 10 mole of CH3COH, and you will have 10 mole of water. That means you can say one thing here. That is 2 minus 10 is nothing but 10 moles. That after reacting, if I have, this is an excess, then in the end, in this situation, what all I have? Tell me. Water, to eventually I will not even think about, right? Let's talk about these acid and bases. In the end, you have CH3COOH and you have CH3COONA. This is there in the solution, right? This is there in the solution in the end. And this is what we want, right? So what they had given you weak acid and strong base, which usually students, in a very quick way, what they do, okay, weak acid, strong base, oh, this must be a question of salt hydrolysis, let's put that formula. But in reality, you have to verify, right, whether the number of moles, some of them, if this is the condition, then it is going to be a buffer. If you have weak acid in excess, then weak acid and strong base are going to react, because here 100% association will not be there. Here 100% association is there. So all of this strong base is going to react with weak acid, and they're going to form a salt, and in the end you have the buffer situation, that is weak acid and a salt of weak acid with strong base, right? Okay, yes everybody, tell me. Now if you see, this is a way of making basic buffer. In a basic buffer, what we do? In a basic buffer, we choose weak base and strong acid. Instead of choosing the salt of strong weak base with strong acid, we are choosing strong acid here, but this is in excess. So here number of moles of weak base is more. Okay, same situation, you have it, let's say this is 20 moles, this is 10 moles, this is 0, this is 0, 20 minus 10, 10 will be left here, 0, all of them will be reacted, and you will have 10 and 10 of this will react, and it will form NH4Cl. Now if you see in this situation as well, what you have in the end, you have NH4OH, that is a weak base, plus NH4Cl, that is a salt of weak base with strong acid in the solution. That means this is a case of buffer. You should not have any extra strong acid in the solution that is left behind. Otherwise, it will not be a case of buffer, right? Okay. Then there is method number 3. Method number 3 of preparing this acidic and basic buffer. Let's talk about that. If they are saying that in the acidic buffer, now something really weird thing they are talking about. This one, though, most of the students get confused here, right? That is, they are not talking about you have weak acid. Usually in acidic buffer, what we were seeing, acidic buffer, we have seen that we have taken weak acid. Here also for acidic buffer, we have taken weak acid. For basic buffer, we have taken weak base. For basic buffer in the method number 2, we have taken weak base. Now it is opposite. Now this particular method is where students get confused, right? Let's talk about it. Let's talk about it. Let's see. In this case, you have strong acid, but here number of moles of strong acid are less. Salt of weak acid with strong base. If you remember what we had seen, what is acidic buffer? Ma'am, weak acid plus weak acid plus strong base salt. Ma'am, that means you should have CH3 COOH and ma'am CH3 COONA. But whatever I give you, you don't have here weak acid. You now have here strong acid. Say, ma'am, it's absolutely wrong. How from strong acid you can also prepare buffer, right? So let's see. Okay. Here you have excess, right? This is an excess. Let's say this is 20. This is, let's say it is 10, right? This is 0. This is 0 initially. Now out of this, what will happen? All of them will be consumed. Here you will be left with CH3COO. Oops. Here you will be left with 10, 20 minus 10, 10. This, so all of this will be consumed. And here it will react with this, will replace this Na here, and you will have the formation of 10 moles of this and 10 moles of NaCl, which is a salt. So you can take it outside as well, right? That means you can see this thing here, which is nothing but this is weak acid and strong base salt, right, with a weak acid. Now we are at the same situation, right? Okay, tell me, understood? Tell me. Same, when you have basic buffer, same thing you're going to do here. Instead, this is the third method of preparation which students usually ignore. They just ratify, they just cram that one definition. No, here this is an excess. For basic buffer, what we know, weak base and salt of weak base with strong acid. Instead of weak base, you take strong base. But here, which one should be in excess? The salt should be in excess. So here, this is 20, this is 10, this is 0, this is 0, right? Then 10 will be left behind, 0, and this will be 10 will be formed here, and this will be 0. Sorry, this will be 10. And here, if you see, what all you will have here is the formation of a weak acid, weak base, and this is salt of weak base with strong acid. Okay? Okay? So remember all the three methods for acidic and basic buffer, right? Now see this question here, JEE means 2002 question that says 1 mole of NaCl and 1 mole of HCl are present in aqueous solution. The solution is what? 1 mole of NaCl and 1 mole of HCl. NaCl is present and HCl is present. NaCl is a salt, right? And this is, if you see, this is a strong acid and strong base salt. This is a strong acid. Can you see this is in any condition of buffer or not? Is this in any condition of buffer or not? Yes, everybody. Do let me know if it is in any condition of buffer. Is this in any condition of buffer? Hanji. This is an acid, strong acid. This is a salt of strong acid and strong base. Right? So we can say because of this very strong acid, the pH is obviously less than 7. That hint I have given you. Now you just have to tell me whether this is a case. Yes, it is not a buffer, right? Why it is not a buffer? The reason being, ma'am, because none of the conditions it is following, so it is obviously not going to be a buffer here, right? Next is 2019 question, which will make basic buffer. Now here if you see, number of moles are given to you, volume is given to you, that means you will calculate number of moles here, right? Directly, it will be tough, but you have to calculate the number of moles here. How do you calculate the number of moles here? Everybody tell me. How do you calculate the number of moles? What is molarity? Molarity is equals to number of moles by volume. If it is, let's calculate the number of millimoles. Okay, I'm not calculating the number of moles, I'm calculating the number of millimoles here. Why you are calculating, ma'am, the number of millimoles? Tell me. Because I don't want to take moles, multiply by 1000, all of these I don't want to do. So I'll calculate the millimoles, that will be molarity into volume. In milliliter, that will be millimole. Okay, so I'll just write it here everywhere. This is 100 into 0.1, that is going to be 10, right? This is going to be 10, this is going to be 5, this is going to be 2.5, this is going to be 10, this is 10, this is again 10, this is again 20. Now see, basic buffer, 3 conditions you have. Either you have weak base, plus weak base with strong acid, or you have strong base. But here obviously one thing, either you have these where number of moles are equal, weak base plus strong acid salt, right? Here if you have this thing, strong base, and this is weak base plus strong acid, here number of moles of this salt should be greater. Or you should have a weak base and you should have a strong acid where the number of moles of weak base are greater, right? Okay, understood? These are the 3 conditions that you have, right? These are the 3 conditions. This you should remember as it is, that what you need here, number of moles of weak base should be greater. Only then you will be able to come to this conclusion. Here the number of moles of this salt should be greater. Only then you will be able to form this for basic buffer. This is for basic buffer. So let's understand. This is a strong acid. This is a strong base. So strong acid, strong base, there is no condition like that. So it is obviously ruled out. Here it is this is a strong base, and this is a weak acid. Strong base and weak acid. Strong base and weak acid. I can't see any condition like that, right? So this is also ruled out. If you see, this is this is a weak acid, right? And this is a strong base. Now, again the same thing, no? Yeah. Weak acid and strong base, number of moles are same. Again, this is not the condition. So we are left with only this thing, that is a strong acid and this is a weak base. And I can see this strong acid and weak base. If the number of moles of weak base are greater than strong acid, then definitely that is the correct situation here. So answer will be D is the correct answer here. Right? Okay. right? So all you have to remember is that what are the conditions, and you have to make them satisfy. If the conditions satisfy, which one, right? And that was the latest question. Only these kind of questions they are asking you. JEE 2020 as well, they are asking the same category of question, that is, an acidic buffer is obtained on mixing what? Now, in an acidic buffer, what is the condition? Tell me. What is the condition of an acidic buffer? In an acidic buffer, first is you should have a weak acid along with weak acid plus strong base salt, or you should have a strong acid and weak acid plus strong base salt. But here number of moles of this salt should be more, only then this is possible. In third condition was you have only weak acid but you have strong base as well, but here the number of moles of weak acid should be more. These are the three conditions that you have. Now if you apply these conditions here, let's calculate the number of, okay, let's firstly do see whether these conditions are applied also or not. This is a weak acid and this is a strong base. Weak acid and strong base, it is possible if here number of moles are more, right? Here number of moles, millimoles are 10, here number of millimoles are 10, so they are equal. They should not be equal, they should be, weak acid should have more number of moles, right? Weak acid should have, option A, no. Weak acid, I am saying, should have more number of moles. So this equation, this first option is already ruled out, right? This is ruled out. This thing you should remember. Now if I say strong acid, this is a strong acid and you have salt of strong acid plus strong base. No condition I have like that. So definitely, if you see this as well, this is also ruled out. Okay. Okay, so this is a weak acid and this is a strong base. Again, you have the same thing, weak acid and strong base. But here, number of moles are 10. Here, number of moles are 20 millimoles, sorry. And here, strong base have more number of moles. So, this is also not correct. If you see here, this is a strong acid and this is a weak acid plus strong base. And here number of moles here is 20. Here number of moles is 10. Strong acid and weak acid plus strong base, this condition you have. And here this number of moles should be greater, that I can see here. So D will be the correct answer. And these are the latest questions where students tend to do mistakes. Okay. So in the end, you just remember this category. Just overall, I'll just also mention, before doing the next topic, I'll also mention this here, right? That what you have to remember. See, all the other slides are just to explain you things. In the end, there is something that you should remember for the exam, right? So for the exam, what you have to remember, so I'll write it over here. For the exam, what you have to remember, I'm firstly writing this box here, then this box here, right? Then this box here, right? Okay, three salts are there. See, three buffers are there. This is acidic buffer. You know how I will mention it? This is acidic buffer so that you can remember this. Now, let's see if you can remember this or not. This is your volatile thing that students tend to forget in the exam, and this is very important. Basic buffer, and then there is salt buffer. Salt buffer I'll mention by this green. Salt buffer. They will never ask you salt buffer because that's quite easy, right? Okay. No, it's not done yet. Acidic buffer, first point is what? You will have weak acid plus, I'll just mention comma here, or I'll mention equal, means number of moles should be same, right? Weak acid plus strong, plus weak acid plus strong base salt. Second is you should have strong acid. Just learn this way. You should have, instead of weak, write strong. And here number of moles of salt will be greater. Instead of strong, write weak here, right? But here number of moles of weak are greater, but here it is with strong base, when no salt is given, right? Similarly, we will remember for this one, that is, you have weak base equals to weak base plus strong acid salt, right? Second is, you will have not weak base, strong base. Here weak base plus strong acid, but here number of moles of salt will be more, right? And the third one is, you will have weak base and you will have strong acid, but the number of moles of weak will be more here. And for salt buffer, just remember that always you will have that thing. You will have salt of weak acid and weak base. Okay, this, so as you have seen, we have done this just one preparation method here, that is salt of weak base and weak acid for salt buffer. So that's why salt buffer you will not get confused in, and they will ask you question where you will get confused, right? So this is the total crux of what we have done till now, right? This is important for you. Remember this for your exam, right? This one page is very important, right? Okay, yes, everybody, tell me. Now I have already told you, those who are asking, ma'am, how you can write this, that also I have told you what is the reason, right? But for your competitive exam, if you remember this thing, this will help. Even if you know all the concepts, you understood everything, but in the exam you are thinking that which should be greater, you are making that, you will end up wasting your time, right? So for the exam, these cheat sheets help you to save your time, right? And these are the questions that are asked recently, right? And students tend to waste a lot of time here, right? Okay, which you will not. Now let's understand pH calculation. Actually, the major part, the difficult part was this only, to understand which is acidic, which is basic, because acidic buffer has a different formula, basic buffer has a different formula. Then to understand whether it's a buffer or not, right? Because if it is not a buffer, you can't apply the formula of buffer there, right? Okay, so that is the reason. Now once you have understood that whether this is a question of buffer or not, now you just need to apply. Now it is the easy part, applying the formula. Everything will be given to you in the question, so applying the formula will be easy for you, right? So consider an acidic buffer. Now we are saying that you have an acidic buffer consisting of HX, that is weak acid, and salt with strong base, that is this one, right? Now, what is going to be the formula of pH here? Let's, either you can understand it this way, or you can just directly understand the formula here, but I'll tell you here. So if you see this over here, Ka for this acid is going to be H positive multiplied by X negative divided by Hx, right? That we have written here, right? Now, X negative, ma'am, why it is replaced by this salt? Why? Anyone of you? Anyone of you can tell me why this X negative? Because it's a common ion. It's the common ion. It's the common ion. From where the maximum concentration of this X negative coming from? From the weak acid. Which one is more dissociated? Dissociation of which one is more? Weak acid is less than, or you can say Hx is less than NaX. This has more dissociation, so X negative is coming from NaX. Very few X negative are coming from Hx. That's why we can replace right? So you can say X negative is coming from which one? Is coming from any. It's like you and your friend has gone for a pizza party, right? It costed you 700 rupees. You paid 600 rupees. Your friend paid 100 rupees. Which one has more contribution? This one has more contribution, right? So we'll consider this one as the one which has paid, right? So here this has more contribution. That's why you can say the X negative concentration is replaced by the concentration of salt. And now what we were doing previously, we'll do the same thing here. You'll rearrange this. H positive concentration is this, then you take the log, you put negative there, same thing, minus log of H positive minus log of Ka minus log of acid, minus will be plus, or you can just simply say minus log of Ka minus log of acid by salt. Okay, I am taking this as one quantity, this as one quantity, right? So when two things are in multiplication, when you take log, this will become log of H is equals to log of Ka plus log of acid by salt. Then you put minus 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 here, then it will become this situation, right? Now if you see what it is becoming, simple, tell me, this is nothing but pH is equals to pKa minus, or you can say plus, this also you can write plus here, plus log of salt by acid. Because when you reverse this is minus here, na? When you reverse, this will become plus, and this is going to be your formula of acidic buffer. Okay, this is going to be the formula for acidic buffer, right? Okay, yes, Kangana, I'll definitely do that, don't worry, right? This is the detailed video that I'm doing right now. Okay. For the ones who are doing this for the first time, right, for them detailed video of this lecture is important, right? So you can say pH is equals to pK log of salt by acid. Now tell me one thing, why we have written conjugate base? Because this is the salt NaX, it is going to give you Na positive plus X negative. X negative, if you see HX, it gives you X negative plus H positive. If this is an acid, isn't this the conjugate base? Can we write their conjugate base? NaX, if you have 100 molecules are giving you X negative. And X negative is also the conjugate base of HX. And that's why instead of salt, you have written conjugate. Because they can say the concentration of conjugate base is this. They can say the concentration of salt is this. Right? This way they can confuse you. That's why we have written both of them here. Right? Okay? So, this one and this one, extremely important formulas for you, right? Very important formulas for you, right? Now let's move ahead. Here for the base, instead of uh, pH there will be POH, instead of acid there will be salt, instead of Ka there will be Kb, everything else is same here, right? Everything else is same here, right? But here you are calculating POH. And ma'am, what will be pH? pH is equals to whatever you have calculated here, you will subtract it from 14, right? pH is equals to 14 minus POH, right? Okay, then you can also write it like salt like conjugate acid. Just like acid have conjugate base, base has conjugate acid, right? Okay, yes. Tell me. Clear? Any problem here? For salt buffer, how do you write it? For salt buffer, you write it like this. For salt buffer, half of pKw plus pKa minus pKb, that is the formula for salt buffer. Right? pH is equals to pKa is plus log of conjugate base by acid, right? pOH is equals to pKb plus log of, or I would just write it here, right? On your cheat sheet only, I'll just take this cheat sheet here, right? And write the formulas here, right? Okay. Oops. You know what we can do? I'll just erase that. Okay. Yes. So if you see, I'll just put this here and I'll put this one here. Okay. And I'll put this one here. Okay. Now corresponding to all these, what are the formulas that you will have? Corresponding to these, what are the formulas that you will have? Right? I feel like, oh my god. Okay. Okay, wait a minute. Okay. Okay. Yes. Just give me a second. I'll just do that and we are done. Now let's see the formulas that you have. What are the formulas? Tell me, guys. Formulas of acidic buffer is pH is equals to pKb plus log of, you can say salt or you can say conjugate base by acid, right? Then what is the formula of pOH here? pOH is equals to why I have written pKa here? This is supposed to be pKb. pKa, not pKb, right? This is going to be pKb plus log of, this is salt, or it can be, in case of basic buffer, it will be conjugate acid divided by base. Okay. What about the last one? Here pH is equals to half of pKw plus pKa, right? pKa minus pKb. pKa minus pKb. And these are the three formulas that you have. These are the three formulas that you have. Okay. This is for acidic buffer. This is, accordingly I am marking it with the pens. Okay. Blue means basic. Green means your salt buffer. Okay. So this is the page that you must remember. Right, everybody? Tell me. Tell me, everybody, in the chat box. Right? Now, let's understand the effect of dilution here. Right? What is the effect of dilution in these cases? Right? Yes. Sure. Let's see the effect of dilution, or we should do the questions. So we'll do the questions. This is a very small topic, the dilution part. Okay. Let's understand that dilution part. For an acidic buffer, this is the formula. Now we'll verify that how on dilution things, why don't they change? Okay. So see this. On dilution, up to small extent, increase in volume is there. Salt and acid are decreased by equal factor. If increase in volume is there, then the concentration, because concentration and volume are inversely proportional. This is increasing, this is decreasing. So both of them are decreasing by equal extent. So overall factor will be equal by equal factor. So there will be no effect on the dilution in general. Same conclusion can be drawn for the basic buffer, that when you add water, right, why there is no effect of adding water into the buffers? Because if this is decreased, this is also decreased, overall effect is cancelled. That is why overall pH will not change here, because this factor has not changed, right? This, see, if you want to change the pH, this factor or this factor has to change, right? Okay, so when you add water here, this will eventually, what is happening, the overall change here, it is also decreasing, this is also decreasing, both are decreasing. That is why overall change is, net change is 0 here. That is why we say on dilution there is no effect, right? Now when you add strong acid, then why there is no effect? Let's understand that. This is from the formulas we are understanding, right? In acidic buffer HA, let's say N1 moles of HA you have, this is N2 moles. X moles of strong acid are added, it will react with A negative. Now you have an acidic buffer. What I told you, in an acidic buffer, they are saying that you have A negative, you have HA, that is N1, and what you are adding here is H positive, right? So A negative, it is going to, see, you have A negative, you have HX. Wait a minute, huh? You have A negative, you have HA already, right? This is a weak acid. That is why dissociation will be less. When you add H positive, it will start making more of HA. Already they are saying that how much amount of HA is there? N1. Already you have added X amount of this, and already you have N2. Now when these two will react, they will form X amount of HA extra, X amount of HA will be formed, that will be added here. If here X amount of HA is added, right, then here X amount of HA will be subtracted, because A negative HA is formed from this and this. If all of this is consumed by reacting with this, then X amount will be subtracted here, no? If I say this is 20, this is the same thing. If I say this is 20, this is 10, then in the end this will become 20 minus 10 and this will become 0. Same thing, right? So that is the reason in the end this will be n plus 1x, this will be n2 minus x. Now they are saying that small amount of H positive you have added. That means this x has a very small value. So that is the reason it will not have that much effect here. So you can say log of n2 by n1 or log of n2 minus x by n1 plus x has the same value here. That's why pH does not change, because the value of this x here that is changing, the change is only the value of this x, and this does not have a, because very small amount of H you are adding here. That is why no change is there in the overall pH, right? Similarly, for base also, effect of addition of small amount of strong acid. Wait a minute. In the basic buffer also, same thing. You have added H positive. This is the base. Base will react with this H positive. It will accept the H positive here. Base will accept the H positive, right? And it is going to react it with it. That is why how much amount of B is reacted? X amount of B is reacted. This will become N2 minus X. Here, how much amount of BH positive is formed? X amount of it is formed. So it is added here. And if you put it in the equation of POH here, this is N1 by N2, this is N1 plus X by N2 minus X. As X has very small value, if you add very small amount of base, then overall effect will be 0. But if you add very large amount of base, then obviously it is going to change, right? According to these equations that we have find out, we can see X should be very small. The extent of H positive added should be very small, right? Okay, only then we can see no overall effect is there, otherwise overall effect will be there. Now if I can see on addition of small amount of base, same thing is there, same thing, right? So what you have n1 amount of this, n2 amount of this, you have added base. Base is going to do what? Base is going to react with the HA that you have here, that is the acid that you have here, right? And here it is going to react here, it will form AOH and it is going to produce H positive, right? Wait a minute, this is no, it is going to react with OH negative and H positive. This will be formed HOH, that means water will be produced and more amount of A negative will be there, because cation and anion will react, no? So A negative will be formed here with this reaction. So A negative form means the amount of OH negative you add, same amount of A negative will be formed. So X is added here. The amount of OH negative will react with this H positive and give you, and this will be converted to A negative. So how much amount of HA is lessened? That is X amount. So again, if you put it in the formula, that will make it n2 plus x, n1 minus x. Again, very small change is there. If x is having a very small value, then it is overall effect is almost zero only. Similarly, when you have addition of strong base in a basic buffer, right? So in a basic buffer, what you have here, we are saying in a basic buffer of B, and BH positive are already there, that is N1 amount of BH positive. So this is a weak base, this is a weak base with strong acid buffer, salt, right? Now we know that whenever you add H, OH negative, salt is going to give up H positive here, right? And it will create B negative here, right? Not B negative because it is H positive, now it will create B only. Initially B2 was N2, N2 amount of B2 was there. If this X amount of OH negative is added, then X amount of H positive will be taken by OH negative and you will have X amount of H2O, right? And you will have X amount of B that is added here. And you will have X amount of B that that is reacted. Okay, and that is the reason in the end again your base and weak base and strong acid salt, their concentration has changed a little bit, minus and plus, and that is why this is the overall new effect that you have. Tell me, is that clear everybody? It is found that, okay, tell me, is that clear what we want to say there? We want to say that X amount that you are adding or subtracting, if that X amount is very large, you're adding good amount of base or acid, then definitely pH, pOH will get affected. But if that X is very small, then it will overall effect will be very less. Okay? Tell me, is that clear? Is there any problem? Tell me guys, is there any problem? Now let's talk about pH range. What is pH range? As I told you, it's not like you add very high amount of acid or base, still buffer is like I will not change, I will not change. Obviously, if the addition of acid or base is very high extent, then you have seen it there as well, that plus x minus x means then the change will be there, right? That means the amount that you have added, the X amount that you have added has a specific range where the pH is not changing. So let's talk about that range. It is found that if the concentration of one component of the buffer is more than 10 times the concentration of other component, then the buffering action is poor. Let's understand that. Concentration of one component of the buffer is more than 10 times the concentration of other component. Let's see what we want to say. This is what we want to say here, right? The ratio should be less than 10 times. This is what we are saying. Concentration of component of buffer is more than 10 times. If I say salt concentration is more than 10 times the concentration of acid, or concentration of acid is more than 10 times the concentration of salt, then it is not a buffer. Then the buffering action will be less. And this, how we are saying it? How to say this in a different way? How do I write it? I can write it by salt by acid should be greater than equal to 10. Here I can say salt by acid is, this is acid by salt is greater than equals to 10. That means salt by acid, if I reverse this, is less than equals to 10. So these are the two conditions, that salt by acid ratio either should be greater than equals to 10 or it should be less than 10, right? This is what we are writing, salt by acid, right? If I write it here, it should be less than 10, right? Or salt by acid ratio should be between 0.1 to 10 here, right? Okay, this is what we want to say here, that there is a specific range of this concentration that you have. That means salt by acid ratio should be 0.1 to 10. Here also it should be 0.1 to 10. This is salt by base. Now, if you take the this here log and all here, what you will see? What you will see here, that pH is equals to minimum pH is what? Minimum pH is let's say this is okay, minimum means this is minimum, this is minimum. If I put it in the formula, I'll just write the formula here. pH is equals to pKa plus log of salt by acid. If I put here salt by acid is 0.1, so this will become pKa plus log of 0.1. 0.1 means 10 raised to power minus 1. Minus will come to this side, pK minus 1. This is log of 10 is this. So this will become pK minus 1, isn't it? That is the minimum value, right? If I say maximum is this value, so if I put this ratio here, pKa plus log of this is 10. Log of 10 is but nothing but 1, so it is pK plus 1. Isn't it the maximum value, right? Okay. Now see this here. This is POH is equals to pKb plus log of salt by base. If we know that the value is going to be what? For basic buffer, we know that this is the minimum value, this is the maximum. On the similar lines, put it there, you will have the value of maximum pOH and minimum pOH. Okay? Tell me, is that clear, everybody? Is that clear? Everybody in the chat box, tell me if that is clear to all of you or not. Right? Okay. So pH range. Buffers are most effective when, for acidic buffer, salt is concentration is equals to acid. So that means pH is equals to pK. It is most effective. When salt and base concentration is equal, then pOH is equals to pK, and they are the most effective in this case. Buffers are most effective in these conditions, right? Where they are most effective in these two conditions. When the concentration of acid and base is equals to 1, Now when this concentration is 1, log of 1 is nothing but 0. So this will be cancelled. This is pH is equals to pK. This will become pOH is equals to pKb. Right? Okay. If you see this over here, minimum value is nothing. If you see, this is the pH range. So I'll just tell you, for an acid buffer having pKa of a weak acid, that is 4.75, pH range can be visualized as. So if it is 4.75, pH range will be 4.75 minus 1, 4.75 plus 1, because this is the value of pKa, right? And we know that pH range is equals to pKa plus minus 1. Okay, this is nothing but 3.75, this is nothing but 5.75. That is the pH range here. So if you see this here, minimum value is 3.75, maximum value here will be 7. Wait a minute, maximum value should be 5.75. Achha, this is the buffer, you know why I'm going there. Huh. So if you see, this is the 2.75, guys. This is 3.75. This point, this particular point is this, that is 3.75, as they have mentioned here, that this is the 3.75 point, and this is the point of 5.75. That is the buffer range here. Okay, right? Now buffer capacity. What is buffer capacity? Usually, so this is not asked, but you must know what is the definition and what is the formula. What if they ask you? Buffer capacity is defined as amount and moles of strong acid and strong base required to change the pH of the buffer solution by 1 unit. You will change the pH of buffer solution by 1 unit, and the buffer capacity is the amount of strong acid and strong base that you require for that. pH of buffer solution is very stubborn. It's like, I don't want to change, right? I don't want to change myself. I'll stay like this only, right? You still want to change it. Then what is the amount of buffer, amount of acid or base that is required to change the pH by 1 unit? How much acid or base will be required? That is called as buffer capacity, right? So buffer capacity is moles of H positive or OH negative added per liter of solution. How much moles of H positive OH negative you have added by how much change in pH. That means how much moles of H positive OH negative to change the pH by unit 1 is the buffer capacity, because if the change is 1, then this will be the buffer capacity, that is moles of H positive or OH negative required, right? Okay. Next, maximum buffer capacity is achieved when salt and acid or base, the concentrations are equal. So you can write this over here. This is the condition of maximum buffer capacity, when it is behaving most effective, right? When less number of this is required, right? Now let's do some questions on buffer solutions. Yes, everybody, let's do questions of buffer solution. Tell me if you're ready for that. Make lectures for chapter, please. Yes, Kanak, yes, definitely I'll do that. Okay. Now let's talk about this now. Here what you have, a buffer solution is prepared in which the concentration of NH3 is this, the concentration of NH4 positive is this. If the equilibrium constant Kb for NH3 equals to this, what is the pH of the solution? So tell me firstly, is this a case of acidic buffer or a basic buffer? You have prepared the concentration of NH3 is this. You have a base, that is a weak base. concentration of this, it has accepted H positive. It is strong acid plus weak base salt. Okay, NH4 positive means they are talking about the, see, if you have a salt that is AX, है ना, A positive, because salt is a strong electrolyte, right? Salt is a strong electrolyte. If you have 10 moles of this, 10 moles of this, and this will be formed. So if they are saying this cation is there by accepting H positive here, that means it is accepting H positive from some strong acid. So this we can say this is a condition of weak, this is a condition of basic buffer. Basic buffer. And in basic buffer, we know how to solve POH. That is pKb plus log of salt that is there, or this is nothing but this is conjugate. Now you will say, ma'am, but how? If you remember, I also told you this is nothing but this is conjugate acid. Acid means after accepting what it is becoming, right? So this is conjugate acid, this is base, right? So you can write this here, pKb value, see Kb is given to you. So this is nothing but minus log of Kb. Kb is nothing but 1.8 into 10 raised to power minus 5, right? Then this is plus log of conjugate acid is nothing but 0.20, and this one is 0.30, base is 0.30. This will become, all the values are given, you will solve the value of POH, then you will solve the value of pH as 14 minus POH. Right? And that's how you will calculate this. Tell me, is that clear? Okay, now rest of the part is calculation only. Okay, log 2 minus log 3, this will become log of minus log of 1.8 plus 5, right? And that's how you will calculate it. Right, everybody? Understood? Tell me, is that clear? Right? Okay, put all the values here, pKb, solve this, right? And you will get your answer here, right? Okay. Next is 2025 question. 25. They have asked buffer solution in 2025, right? So if you see, in 2025, what they have asked you, let's understand that. They have asked 1 liter buffer solution. How much liter? 1 liter. 1 liter buffer solution was prepared by adding this much of NH3 and NH4Cl. That we can say it from here only, that this is a case of basic buffer. Basic buffer is there, right? This is the weak base, and this is salt of weak base and strong acid. This is salt of weak base and strong acid, weak base and strong acid. Achha, one more thing. If you see this here, understand one thing. Achha, here to they have given that this is a buffer solution. Okay? So you don't need to worry about it. But here, in deionized water, the change in pH on addition of 0.05 mole of HCl to the above solution is this. Change in pH is this, okay? pKb of the solution is given and this is given, okay? Right. So let's understand this thing. By addition of 0.05 mole of HCl, what is the change in the above pH? That means some buffer capacity is there. You have added enough HCl to make some change here. And this is also given that this is a buffer solution here, right? This is already given that, guys, this is a buffer solution here. Right, everybody? Tell me. Okay. Let's understand this particular question here. Right? So firstly, we need to understand that what exactly is going on here. This is NH3, right? Here, this NH3, when you add H positive, this will get converted to NH4 positive. This will happen here. When you add H positive, this is the thing that will go here. Right? The amount of H positive they have given you, and they have already given you 1 liter of buffer solution is there. So volume to will remain constant throughout. 0.1 mole of NH3 you have. That means they've already given you that this is 0.1, and how much H positive you have added? 0.05. So how much after reaction what will happen? 0.5 minus 0.05, this will become 0 and this will become 0.05. That means more amount of 0.05 NH4 positive will be there, and from here 0.1 minus 0.05 will be subtracted from here, right? Now in this situation, you have to calculate the change in the pH that is there. That means two pH, one is from this part, other is from this part, NH3 and NH4Cl. These two pH you will see, right? Okay. Firstly, though, you have this concentration, you have this moles of 0.10 moles of NH3, and this is there. See, if the concentration of weak acid in this is same, then we know that pH equals to, do you remember pH is equals to pK? Array here, but we have basic buffer, so POH is equals to pKb. pKb is given to you, that is 4.745. So pH is equals to 14 minus 4.745. This is the initial pH. Okay, this is going to be the initial pH here, right? Everybody, tell me. Wait a minute, we'll just subtract it. This is going to be, initial pH is 14 minus 4.745 है ना. So 9.255, I'll take the exact value only, 9.255. This is the initial. When I am not adding anything, I am just saying this is a weak base, this is a strong acid. Now whenever the number of moles that is same here, when number of moles are same, then according to the definition of buffer capacity also, when the number of moles of both acid, both the things, that is in the weak in the basic buffer, you can say weak base and the salt, if they have the same moles, number of moles, then we will say that in this case they have maximum buffer capacity, their action is maximum. So POH is equals to pKb, that is this. So pH is equals to 9.255. That we can say. This is the original. Now what about pH calculation from here? Right? How do you calculate the pH here? Here H positive concentration will be this. This is 0.1 minus 0.05. This is your base calculation here. Right? Now let's understand in this fact how do we answer it. Right? Now the value of POH, again in this case POH, I'll say it as POH after, right, it is going to be PKB. What is PKB? Tell me. PKB is 4.745 plus log of, what is salt here? Here, which is the salt here? This one is the base, this one is the salt. So it will be 0.05 and this will be 0.1. This is the base, that is 0.1 minus 0.05, and that is going to be wait a minute. one thing, na, one thing we need to see here. That is, if this is point 1, this is also there, na? From here also you will initially also, from here also you will have point 1, right? So initially this is also present in the solution. Yes. Okay. Now initially it is point 1. You will add plus 0.05 here, this much amount, and here this is point 1 minus 0.05. If you remember that case, plus x minus x, right? So this will be point 1 plus 0.05. This is going to be, do you remember that thing that we did, plus x minus x, point 1 minus 0.05? Okay, beta, do you remember these formulas that we did, plus x minus x, right? Okay, this is the case of when you have you must have done this case here, right? When you add strong acid, plus x minus x, x is the amount of acid that you add. Okay, based on that they have asked you the recent question, right? So now nothing is there, you just have to solve this thing here, calculate the value of POH. From solving this, calculate this value, and then delta of P, then after this calculate the value of pH is equals to, pH dash is equals to 14 minus POH dash, right? Calculation will be a tough task here, right? But I think you can do it, है ना? It's not that of a tough task, but still, right? Delta pH is going to be pH dash minus pH. Okay? Okay? pH we have calculated here. pH dash you can calculate from here, and you can calculate the value of delta pH, that is the change in pH, and this is your JEE 2025 question. Right, everybody? Tell me, is that clear? Which is that, Pritija? I can only see, please answer me, ma'am, but I can't see your question. Right? Okay, you can see the calculations over here and you can do this yourself as well. Now let's see. Next question, that is JEE 2024 question, right? Buffer, can you see latest they are asking you, right? Right? Let's see that. The pH of, now we are saying the pH of an aqueous solution containing 1 mole benzoic acid, that is pK. The pH of an aqueous solution containing 1 mole of benzoic acid, 1 mole of sodium benzoate. Benzoic acid is a weak acid. Okay? Sodium benzoate is a salt or weak acid in strong base. So they are talking about acidic buffer, because here see buffer is mentioned here. The volume of benzoic acid is 300 milliliter of this buffer solution. The volume of benzoic acid solution in 300 milliliter of this buffer solution is how much? Okay. How much benzoic acid is there in 300 milliliter of this buffer solution? Right, so what you have to calculate is, you have to calculate the concentrations, right? From there you will calculate it. Okay, you have chalo, let's see that. Ready, everybody? Tell me, everyone in the chat box, if you're ready for that. Right? Okay, ma'am, this lesson, yeah, if your basics are clear, if you're in class 11th and your basics are clear, or in, sorry, if you're in class 12th, your basics are clear and you're preparing for JEE means 2026, right? Then at this point, the JEE advance you can do, but 40 days before you should focus on only on JEE means. But if you are in class 11th, you're asking me JEE advance, is this important? Then see, if you're watching this lecture for the first time, then obviously this is important. But if you have watched all the important detailed lecture of ionic equilibrium, then you want to study like advanced good level questions, more better questions of ionic equilibrium, then advanced sessions will do, right? At this point, I'm focusing on JEE mains, right? Okay, topic I am not leaving, but questions, see, topics will remain the same. The kind of question that they will ask will change, right? So topic I am not leaving. Topic for the concepts, it is good. So pH of aqueous solution, that is given to you, right? So we can say that this is benzoic acid, right? Benzoic acid accepts H positive and it will get converted to benzoate. No, why we are saying benzoate accepts H positive, right? No, 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 right? Let's see this thing. You have benzoic acid with pK value is there. Wait a minute. pH is also given. pH of aqueous solution containing this much of pK is this, this is this. Okay. The volume of benzoic acid. So that means we have to assume the volumes here. So we have to convert it into the form of volume. So what we will do here, see, we know this formula here, that is pH we know, pKa we know, right? But now if you see, the concentrations are also same here, right? So if you see, how do we calculate this? We know that number of moles is equals to concentration into volume. So we have taken the volume of acid as A, volume of salt as S, because we know the volume of one of them. What is given to you? Volume of this much of the buffer solution. Overall solution is given to you, right? That means Vs plus VAA is given to be 300. This thing is given to you. Overall solution is given to you, right? What we will do, we'll take the ratio of this here. Instead of putting them in concentration, we are putting them in volume, because if you see, molarity is directly, if you see concentration, this is going to be, concentration is the number of moles is going to be this, yes. So you can, instead of putting here concentration, you can directly put, because molarity is 1 here. So how many millimoles are there? Millimoles are, see, what is number of moles? Na? This is volume into molarity. Molarity is same here. So we can say millimoles is equals to volume. Volume we have assumed here. This is, let's say, volume of an acid is A, volume of salt is S. Molarity is given to you. So that's why millimoles is Va and Vs. You put the value of millimoles here, right? Once you put the value of millimoles here, right, you have this value is given to you in the question. Solve this, Vs by Va, that is 2. Now you have these two equations, then you have to just solve it. You know, Vs by Va is equals to 2, Vs plus Va is equals to 300. Solve this and you will get the value of what they are asking you. They are asking the volume of benzoic acid. That means you have to solve the value of Va, that is acid. So you can do one thing, take the volume of salt from this, and Vs is equals to 2 of Va, put it there and you will get the value of Va here, right? Okay, understood? Yes, everybody, quite a simple question. Then it is JEE 2022 question, that is class 12 students were asked to prepare. Now let's see what they are saying. Ma'am, only 1 month to go. What to do, advise me. Tell me what is your query right now. To just focus on high weightage topic, important topics, and uh, on this Wednesday we are going to take up we are going to do something, like we are going to tell you the plan, right? We are going to tell you what we are going to do, right? What is going to be your focus, right? So don't worry about that. We are working on that right now, right? So don't worry about anything, right? For JEE 2026 aspirants, will from Wednesday you will see that full on JEE English team will be here only with you every single day, right? So class 12 students were asked to prepare 1 liter of buffer solution, that is pH this, by their chemistry teacher, Diksha Ma'am maybe. The amount of ammonium chloride to be dissolved by the student in 0.2 ammonia solution to make 1 liter of buffer is what? Now they are saying pKb is given to you. This is a basic buffer that we can see here. pKb is given to you. Basic buffer it is. Prepare 1 liter of basic buffer. pH is this. See, if pH is going to be this, pOH is going to be 14 minus 8.26. You know the value of pOH, you know the value of pKb, right? Log of salt by acid, if you see the concentration, the amount of ammonium chloride to be dissolved in this ammonia. See, if you know log of salt by base, na, ammonium chloride, 1 liter means volume is 1 liter only, so that's not the problem. Salt by base. Achha, they have given you grams here. So what you will do? You will convert it into weight, right? Because see, if you talk about this thing here, pOH, pKb plus log of salt by base. We know this thing, you can calculate the value of log of salt by base, right? And if you see the amount of ammonium chloride, salt you don't know, dissolved by student in this much of ammonia. You know that this is the molarity of ammonia. So from there you can calculate the molarity of salt. Once you calculate the molarity of salt, molarity is equals to what? Number of moles, molarity is equals to number of moles is what? Molarity by volume. And they are saying 1 liter, 1 liter, 1 liter, right? The amount of ammonia to be dissolved by a student in this much of it to make 1 liter of buffer. Overall, it is going to be 1 liter. 1 liter of buffer solution. Overall, it is going to be 1 liter of buffer solution. Okay? Molarity of salt, you will know, right? That this is the molarity of salt. From there, you will calculate the number of moles, that is molarity into volume. From there, calculate number of moles equals to molar mass by weight. Weight by molar mass. Okay, molar mass you put, you will calculate the value of weight there. Right? So once you know the log of salt by base, that is basically from here, once you have calculated this value NH4Cl, right, that is coming to be 2 molar. Right, now number of moles is what? Molarity into volume, that is 2 moles, because volume is in liter. Now weight is what? 2 moles multiplied by molar mass, and that's how you get your answer. Understood now? Just solve the concentration. This is nothing but molarity into volume in liter. This is molar mass. This is moles. Right? So it was also quite a simple question only. Right? I mean, I won't say it was a like complex question. It was just just calculation of concentration was from buffer, and after that it was just simple mole concept only, right? Okay, yes, everybody, tell me if that is clear to all of you or not. Tell me if that is clear to all of you. Now before starting solubility, solubility we'll do in the next class, right? We have two very small topics that we are left with. One is solubility and one is salt hydrolysis. That is very important, right? One is salt hydrolysis and one is solubility, right? Nahi Pritisha, I have not right now. So see one thing, relationship between Ka and Kb. Now this is the case. Let's consider NH4 positive and NH3 conjugate base pair. So let's say this is the base and this is conjugate acid. Okay. So if I say this is the base, base will have Kb, right? Base will have Kb, and Ka, that is for conjugate acid. Conjugate acid is going to have Ka. Now what we can say that if I talk about for an acid, that is conjugate acid, acid is going to always donate H positive and it will be converted to NH3 and and this hydronium ion. Base is always going to accept H positive and it will be converted to NH4 positive and this is OH negative. Now if you see here, it will be Ka and for this it will be Kb. Product by reactant, so NH3 hydronium ion divided by NH4 positive, because these values are going to be one only because pure water has unity in the is unity in the value of equilibrium constant, right? This one is product, that is NH4 positive OH negative divided by NH3. Now what we have seen, that the product of these two, when you take the product of these two, what you will see, NH3 NH3 will cancel, NH4 NH4 will cancel, and what you will be left with, these two things, right? So what we have seen, the product of Ka into Kb is equals to hydronium ion plus multiplied by OH negative, that is nothing but Kw. And this is the important thing, that Kw is equals to Ka into Kb. And this Ka and Kb is not like Ka is for some other acid, Kb is for some other base. No, this is only applicable to conjugate acid base pair, only to conjugate acid base pair. Only to conjugate acid base pair this is applicable, otherwise this is not applicable, right? Okay, yes everybody, tell me, right? So we can say, as the strength of an acid increases, as this is increasing, because this is constant, so this should decrease. As the strength of an acid increases, now do you remember that I told you, whenever you will have an acid, if this is strong, this is going to be weak. Do you remember? I told you, for a strong acid, there will be weak conjugate base. For a weak acid, there will be strong conjugate base. For a weak base, there will be strong conjugate acid. From a strong base, there will be weak conjugate base. It will always be opposite because the overall value has to be constant. So when this is increasing, this will decrease, and hence its value, its basicity is going to decrease, right? Okay, so as the strength of acid increases, the strength of its conjugate base must decrease, so that product remains constant here, right? And if you see this, when you solve this, this is only for conjugate acid base pair. You take log, you take negative of that, and you will have this particular thing here, which is equals to 14 at 25 degrees Celsius, because Kw values changes with the temperature here, right? Tell me guys, is that clear? And that's it for today, and we are done for today, right? Buffer solution, we are done, right? And day after tomorrow, on Wednesday and Thursday at 6 a.m. in the morning, I am taking chemistry classes for chemical kinetics and solution chapter. Right, so all the students who want to do good practice of questions, please join in the session at 6 a.m. in the morning. It's hardly 40-45 minute session, but that is going to recap all the category of questions that they ask you in the exam, right? Okay, yes everybody, is that clear? Tell me. Done? Okay, so that's it. And now, one thing before going, this is your homework question, everybody. Take the screenshot of this one, which will make the basic buffer, and I'll see that how many of you answer this in the comment section. I want to see if, because this buffer solution is a very important topic. As you have seen, latest year they have asked you questions from buffer solution. Buffer solution, salt hydrolysis, and solubility. These are three, like, I know nothing else is there, but what to do? They ask you questions from here repeatedly, right? Okay, yes. So if I see here something very important for you, first is hit the like button, guys, and also if you see this here, click on this link and you will get the PDF for this session. And also, if you have any doubt, because if you're in class 11th, I know you have read this chapter for the first time, you might have so many doubts, because I will not be able to answer you in a recorded version. In a live, so I definitely answer, but in the recorded version I will not be able to answer, but this Ved can answer, right? So ask your doubts here, click on the link, whatever you have, whatever doubts you have, ask it here, so that in recorded version also it can help you. And also, guys, if you see this here, this is the test series that is specially for JEE 2026 aspirants, where what we are doing is we are giving you 11 parts test and 25 full syllabus test. Along with that, we are also providing you 93 high weightage topics. Test provided, like this is not in a scheduled manner, 93 high weightage topics that we have collected from physics, chemistry, and maths. Like each topic will have their specific test, and these are high weightage topics, right? So it is going to help you a lot. And this is just at a price of triple nine, which is a like triple nine, 25 plus 11 plus 93. So you can easily see how many, and video solutions are also provided for the full syllabus and part syllabus test. So all of that is there at just triple nine rupees, right? Okay, yes. So that's it, students. Now I'll see you all in the next class. Till then, bye bye, take care, and write down the homework question in the comment section. And what was the homework question? This one. Write it down in the comment section. Let's see how many of you are able to solve. Bye bye.